Hello everyone, let us see now next example of Fourier series. Find Fourier series for the function fx is equal to mod x. Mod means whatever the negative sign it conjuncts within the mod. Means mod of x is a positive term always. In short, in the mathematical term, fx is a mod function is a even function. Okay. Now to find out the Fourier series for this function for the series for the range minus pi to pi, and we also prove that this pi square by 2 is equal to, as usual, this star series. First let us see the range is minus pi to pi, and whether, but obviously it is a even function, but we have to prove it is a even or odd. F of minus x, put the minus x on the both side, we get minus of mod x, and we know minus x mod x plus mod x, which is also original function. Therefore function is even. For even function bn is 0. Now a naught is this formula, rho upon pi integration 0 to pi fx dx. Put the value of fx is mod x, and we know mod x value is positive in the range 0 to pi. 0 to pi is a positive range. Minus pi to pi, how it should be? It is 0, this is suppose pi, but obviously this is minus pi. These are the negative values of x. These are the positive values of x. Therefore, in 0 to pi, this limit, all terms are positive. Therefore, mod of x becomes x. No negative terms, that's why. Dx. Now, take the limit of integration x is x square by 2. Putting the limits, we get answer pi for a naught. Now for an. Formula for an is 2 upon pi integration 0 to pi fx cos n x dx. Now put the value of fx is mod x. Again we know mod x value greater than 0. That's why 0 to pi is a positive term. That's why mod x is equal to x. Again here we have to use u into v rule. Rest of the terms as it is. 2 upon pi u into integration of cos is this minus x derivative here. This integration here as it is as usual. Limit 0 to pi. These are the reason. Okay, need to write here. Okay, now minus minus plus for again sign limits for the both the limit sign terms 0. Only you have to consider cos. Minus minus becomes plus cos this 0 to pi. Put the upper limit cos of n pi minus cos of 0 is 1. Take this n square outside. Answer of this is 2 upon pi n square minus 1 raised to n minus 1. Therefore Fourier series is given by fx is equal to a naught by 2. This is a n cos n x. Fx is equal to mod x. A naught by 2. A naught is pi by upon 2 plus summation over a n is this cos n x. Take the 2 upon pi outside of the summation. Summation is over n. That's why these are all n terms. This is the first answer for Fourier series. Okay. Now we have to prove that the sub question. What is the sub question? Sub question is this pi square y. Therefore, put x is equal to 0 in this above equation. How we get mod of 0 is 0 is equal to pi by 2 plus 2 upon pi cos 0 is 1. Rest of the terms as it is. Now we have to expand this. Take this pi by 2 on this side. Minus pi by 2 is equal to 2 upon pi. Put n value 1, 2 and so on. For n is equal to 1. Minus 1 raised to 1 is minus 1. Whenever odd value is there for n, it becomes minus 1, minus 1, minus 2 for odd. For the even, minus 1 square raised to 4 becomes plus 1, minus 1, 0. Even terms gets vanished. Therefore for 1, start with the 1, minus 2 upon 1 square, minus again 2 upon 3 square, again minus 1, minus 2 upon 5 square and so on. Okay. Now multiply, take this 2 upon pi on that side, we get pi square by 4, and take this minus 2 common from the all the term. We get this 1 upon 1 square, all the term gets plus 1 upon 3 square, 1 upon 5 square and so on. Now cancel out this minus throughout and take this 2 on this side, we get pi square by 8 is equal to this series. Okay, let us see next example. We have to find out Fourier series question is same. F for the function fx is equal to x cos x in the range minus pi to pi. Plus, first find out whether the function is even or odd. F of, put the minus x on both sides. F of minus x is equal to minus x cos of minus x. We know cos of minus theta is plus cos theta. Therefore, answer is minus x cos of theta. And it is minus this original function f of x. Therefore, whenever the function is there, f of minus x is minus fx, we get the function is odd. For odd function, we know a0 and an both are 0. This is the benefit of even or odd function. Now calculate, we have to calculate only bn. Now bn is equal to 2 upon pi integration 0 to pi of x sin n x dx. This is a formula for bn for the range, this range. Now put the value of fx is x cos x sin n x dx. Now we have to, there are the three functions, therefore we have to use sin a cos b formula. Therefore take sin first and cos later on, and we have 1 by 2 here outside the formula, sin a plus b plus sin a minus b dx. Now 2 gets cancelled, 1 upon pi x into this first integration plus integration 0 to pi x into sin this second integration. Okay, now again you have to use u into v rule, here also u into v rule. Again make this curly bracket because 1 by pi is there. First integration, for suppose start with u into v rule. U into integration of sine is minus cos n plus 1x. Take the common x also from the both the bracket. Upon divided by derivative of this is n plus 1 because it is a constant. Minus x derivative here. This integration again here. Minus as it is cos integration is sine n plus 1x upon n plus 1, already n plus 1 square. Next term will be plus 1 derivative 0. Therefore, first integration stops here. Limit 0 to pi. Now, second integration plus u into integration of sine. What is the difference between these two? Only angle is different. That's why rest of the terms are same. Only angle get difference. Okay. Limit 0 to pi. Curly bracket complete for the whole sentence. Whole the step. Now, we know for the series sine, for the lower and upper limit it get vanishes. Okay, therefore we are consider only these two terms, minus x cos n plus 1x upon n plus 1, and this is again minus x cos n minus 1 x upon n minus 1, 0 to pi. Put the limits first and take this, in the next step take this minus outside of the integration, minus 1 by pi, and put the value of upper limit first, pi into cos of n plus 1 pi divided by this, minus take already we have taken outside, plus pi cos of n minus 1 into pi upon n minus 1. For lower limit we know it is 0 because if we put here 0, here 0 x value, it becomes lower limit 0. Okay, now take this pi outside, cancel with this pi, minus as it is the bracket cos of, take this pi inside, pi plus n pi, and plus this cos of pi n pi minus pi. You can reverse for the cos because cos of minus theta is plus cos theta. We can reverse this angle. Cos of pi plus n pi, cos of pi minus n pi is nothing but minus cos theta n pi, and then minus cos n pi here both the side. Therefore it becomes here cos of pi plus theta is minus cos theta, cos of pi minus theta is minus cos theta, again same. Therefore it becomes minus cos n pi, and again minus, again we are reversing this term, pi n pi minus theta and pi minus n pi. We are reversing this angle because cos of minus theta is cos theta, and we know cos of pi minus theta is minus cos theta, therefore it is minus cos of n pi. Cos of n pi value is, we know, minus 1 raised to n. For only few things we have to mug up in this chapter. Okay, now take this minus outside, cancel with this minus, take this minus 1 raised to n outside, 1 upon n plus 1 plus 1 upon n minus 1, cross multiplying we get this, and a plus b into a minus b, n square minus a square minus b square. Numerator becomes 2n, this as it is. And if you observe this denominator, our n value start from in the summation 1. If you put n is equal to 1 here, 1 minus 1 is 0. Anything raised to 0 is infinity. That's why we have to neglect 1. N is equal to 1 value here. The series will start from n is equal to 2. And for n is equal to 1, we have to calculate separately an and bn. In this particular example, only b1 only, because an is 0. Okay, this is an extra thing we have to calculate in this example. Whenever the denominator is 0 for n is equal to 1 or 2, maybe anything. Okay, now for n is equal to 1, we are going to calculate b1. For that, bn formula is this. Put the n value here on the both side. We get b1 is equal to 2 upon pi integration same here 1 sin x dx. Okay, put the value of fx is equal to x cos x, function value, and we know 2 sin x cos x equals sin 2x. Take this 2 inside. 2 sin theta cos theta is sin 2 theta. This is the formula here. Okay, this x as it is, the 1 by pi as it is, u into v rule we are going to apply. This is u into integration of sine minus x derivative here, this integration here, as usual, 0 to pi. Put the brackets everywhere. Lower limit bracket, every integration becomes, we have to put brackets. Now again sine terms gets cancelled for lower and upper limit. This is the only remaining term, x minus x cos 2. Put the value of pi upper limit minus pi cos of 2 pi upon 2. For lower limit it becomes 0 every term. Okay, therefore pi gets cancelled, minus here cos of 2 pi we know 1. You can calculate all these terms and calculator. Cos of 2 pi means cos 2 into 180, it becomes 1. Okay, 1 by 2 is the answer for b1. Therefore, how to write down now? Fourier series. Fourier series, Pn is 0 but obvious. A naught is this. The Fourier series is given by fx is equal to summation Pn sin nx, because a naught and an are already 0. Put the value of fx here, x cos x is equal to, now we have to first put n is equal to 1. We get b1 sin x plus summation start from 2 to infinity, because we are already calculated b1 separately. Therefore we have to, in the for writing down our answer, we have to make sure we have to write down the first term separately. Okay, therefore now put the value of bn is minus half sin x plus summation over n to infinity. Bn is this minus 1 raised to n, 2n upon n square minus 1 sin nx. Okay, now put, this is the answer for, take these two constant outside of the summation only. This is answer for Fourier series. Okay, now next example. Find Fourier series for the function fx is equal to pi square by 12 minus x square by 4 in the series in the range minus pi to pi. Now we have to decide whether the function is even or odd. F of minus x, put the x minus x on the both side, we get pi square by 12 minus x square by 4. Minus x square, it becomes plus x square by 4. This is the same function we are getting, therefore function is even. For even function bn is 0. I start with the a naught, 2 by pi 0 integration 0 to pi fx dx. Put the value of fx here. It's very easy. X square integration is x cube by 3, 1 integration is x. By putting the limits, we get a naught is 0.